Hello guys, this is James and today we're gonna delve into the ax equals to 1. We want to find the vector space of x. So here we get a matrix A, and then the first thing we have to do here is to do the elimination, right? Like we use the linear combination to do the elimination. And here we got 3 rows, 4 lines. So it's a 3 by 4 matrix. And then let's try to do the elimination. The first thing we'll eliminate the 2, right? So we can get 1, 2, 2, 2, 0. It will also be 0. So it will be minus 4, 2, and 4, 3, 6, 5, 10. And also we will eliminate the last one. The last row will be 1, 2, 2, 2, 0, 0, 2, 4. It will be 0, 0, 2, 4. And it can also have further elimination here. 1, 2, 2, 2, 0, 0, 2, 4, 0, 0, 0, 0. Okay, here as we can see that the last row will always be equals to 0. It means that it doesn't really contribute to our equation x even equals to 0, or it means that the last row is not independent from the first and second row. Or we can say that again, the first and second row can really deduct the last row. All right, and then here we have an idea of rank. So what is the rank? If we see that how many independent rows or columns we get, it is the rank. And since the independent row will be 2, and the independent column will be seems 4 or 2 or 3, right? So the rank, we give it a. So when we have a rank 2, it means that we have 2 variables, that is 3. And no, actually 2 minus 2 equals 2. That's 2 variables of 3. And here we can have 1, 2, 2, 4, 0, 0, 2, 4, 0, 0, 0, 0 with x1, x2, x3, and x4 equals to 0, 0, 0, 0. What we can do here is first have 2 equations. 2x1, no, x1 x2, x3, x4 equals to 0, and 2x3, x4 equals to 0. Well, so since we think x1 and x3 are those variables, that is not free, and x2, x4, those are free variables. So we can have x2 and x4 equals to first 1 and 0. And then let's try to get the value of x1 and x3. x1 equals to, since x4 equals to 1, so right, x3 will equals to 0, 2. x3 will equals 0, 2, and x1 will equals to 0, 0, 1, minus 2. So there's one solution here. 0, 1, no, 0 minus 2. There's something wrong here. x1 minus 1. Solution is minus 2, 1, 0, 0. And if we can really observe that, if we put a C here, any of the C times minus 2, 1, 0, 0, it always will have the solution 0. And that's how we write. That's this one minus 2, 1, 0, 0 is a special solution. And then we have another a special solution. X2, X4 equals to 0 and 1. And let's see if this one is the case. X4 equals to 2. So X3 will equals to minus 2. And X1 will equals to, let me check, 2, 0, X3 minus 4. This will be minus 4. And this one will be 2. So X1 will be 2. So there's another special solution or values 2, 0, minus 2, 1. And that we can find out that any D, right, times this solution, always we will get the solution will be 0. So another question is that, so we can have a linear compilation of those two. And is there any cases we're having not included here? Actually, no, because for the free variables, it only have, right, if we have 1, 0 or 0, 1, it has included all the case of these free variables. There's no exception already. And because of that, and our not free variables will depend on all the cases of those free variables. So it also will be all the case of the not free variables. And if we use C plus D, it really have encompass all the cases here. And of course, the two special solution here is minus 2, 1, 0, 0, and 2, 0, minus 2, 1. So this is the vector space because it also include the 0, the origin here, right? When C and D equals to 0. And also it includes all the vector spaces here when C and D will be different, values out there. Okay, we have got the vector space. All right, here we have some further elimination. So here what we got is 1, 2, 2, 2, and 0, 0, 2, 4. What we're gonna do first here is to the second row by minus 1 and add to the first row. So the first row will be 1, 2, 0, minus 2, elliptic 2, and then we get also scale 2 out from it, because as we know that we just solve the equations, we can always have the scales out. Okay, so eventually it will become 1, 2, 0, 2, minus 2, and 0, 0, 1, 2. And then we just exchange the column because, of course, in resolving the equations, we can exchange the column. So then eventually it will become 1 and 1, and then the rest of it will be 0. And then here we have 2, minus 2, and 0, 2. So now we have to think it as a block. So the first block will be identity. We got some sort of identity matrix, and here is F, and then the rest of the will be 0. And then the question is that if we get something like this, then if we multiply it by something here, then it will be, everything will be 0, right? That's the question. And so what will be here? Actually, I think it's something very simple. It should be minus f and the I, because as we know that by block, this will be something like the first will be I minus I plus f, right? That will be the first. And then the second will be, no, there's no second. I'm thinking there will be 0. So the result will be 0, 0, 0, 0. Because of course, as we know that I, in our case, I stands for 2 rows and 2 columns. F also stands for 2 rows and so 2 columns. And eventually we'll get everything 0, 0, 0, 0. As we say that, so what is the minus f? Minus f is, here is the I, f, right? Minus f here is minus 2, 2, 0, minus 2. And then the I, of course, is 0, 0. So this one is just this one. Then we just compare with our result here. Minus 2, 0, 1, 0. Minus 2, 0, 1, 0, 0. And then 2 minus 2, 0, 1. And then we have to exchange the second row and the third row, because earlier we have exchanged something here. So here we have changed back. So eventually we'll get something like minus 2, 1, 0, 0, 2, 0, minus 2, 1. So that's exactly what we have got here. The conclusion. If we really have eliminate our matrix and ends up something like this, then it can be easily to solve what kind of what's that? The column space we want to get is something here. And to illustrate it better, let's have another example here. Now we have something like 1, 2, 3, 2, 4, 6, 2, 6, 8, 2, 8, 10. And then we want to get all the vector space of X. So what's the first step? Of course, we try to get something like IF 0, 0, something like this first. And so we start from here. First, we just want to make this 0, right? So we got 1, 2, 3, 0, 0, 0, 2, 6, 8, 2, 8, 10. Something like this. All right. And then we have to make also those a 0. So we just exchange the row, and also we just make it something like this. And here, actually, what we have got is still is not enough, because we also want to make this 0. All right, there's a mistake here. So it's not 4, actually it's 2, because we use the -2 to the first row to multiply it by the -2 and then add it here. So that will be 0, 2, 2, not 0, 2, 4. So it will make it simple, because since here we got 2, 2, and then we can really make this also 0, 0. Because you use this to multiply by the -1 above 2, right? Or 0.5, and then add to here, it will become 0. So eventually what we get here is this, and then it can be easier to make the block. Here is what we make the block. All right. And the next step is that we have to really identify the I and F. This is I, and this is F. So the X will be something like -I Fi. That's our X. And then it will become F is minus 1. And then I will be 1, 0, 1, 0. And here we just got, right, there's something wrong. So minus f is something like -1, -1. So we have to design the what's I, because it has 3 column and it has a rank of 2, right? Because we have see the rank 1, 2, or even here we have the identity matrix that is 2. So -2 equals to 1. So I only have 1 as the identity here. So what we got is -1, -1, and 1. So eventually, that's our vector space or column space. All right, so by the example, we can see that how we can write by the using AX equals to 1, how we really get the vector space of X. And sometimes, right, we get it will be something compilation, something like this. But in other cases, we will just get one like this. Of course, we can add a D here. How to decide the I here? It's really use the column, then we load the rank and it equals to the I here. All right. So that's for today about AX equal to 0. Next time we will solve something like AX equals to B. Let's see how to solve that and if we can really find some vector space. I'll see you in the next